Hi all, welcome to our second session on our Pivotal Cloud Foundry course. Today we are going to study on different cloud technologies. On our previous class, we have gone to know what is virtualization and going through different types of virtualization. Today our focus will be to get more accustomed with infrastructure as a layer services as well as platform as a service as well as software as a service. This will basically be a entry point for us to know about the core concepts of our Pivotal Cloud Foundry platform. Let's get started. So cloud computing is basically a mean by which we can access the applications as utility over the internet. It can allow us to create, configure and customize applications online and on the fly. Unlike in a traditional systems where we need to configure services in a static manner, with cloud computing, we can access the database resources online via the internet anywhere and everywhere as long as they are accessible without to worry about the maintenance or management of the actual resources. The term cloud in a broader sense refers to the whole network or the internet. So by default, it means something that needs to be accessed from a very remote location. So cloud is need to build or provide services to the end users or the clients who need applications or services that are not located in their own infrastructure workspace. So for example, you can imagine that I'm using a particular CRM application. That CRM application is hosted somewhere in the cloud domain, and we can access that application irrespective of the location and the time zone. So this is possible because of the introduction of different cloud technologies in our IT infrastructure. So cloud provides services over a wide variety of network that includes WAN, LAN or VPN. Cloud computing, it basically refers to the manipulation, configuration and accessing the applications online. So it offers online data storage, infrastructure and application. On an overview level, if we see, the picture looks like this, where we have the storage, application and the infrastructure residing in a central shared location, and the clients that can be a workstation, end user device such as mobile, tablet, PC can access that information across any place. The entire network connectivity is defined in a manner so that the accessibility is provided without any hiccups. That means without any network transients, and can be, and for the end user, in the application accessibility becomes user accessibility becomes more viable. Let us delve or study a little bit on the cloud basic concepts. So there are certain services and models works behind the scene which makes cloud computing feasible and accessible to the end users. Broadly classified, cloud model is divided into two different types. One is the deployment model and one is the service model. Let us go through to know about deployment models. Deployment models is broadly classified into four different cloud types, which are public cloud, private cloud, hybrid cloud, and community cloud. So what are they? Public cloud. Public cloud allows the system and the services to be accessible anywhere on the general public domain. Because of its accessibility across any part, anywhere, it becomes less secure because it is more prone to openness. Private cloud. Private cloud basically allows systems and services to be accessible within an organization's infrastructure. That means you can only access the services if it has been permitted by the organization to allow that specific services to be accessible on a public domain. Because of its limited openness, it offers greater security compared to public cloud. Community cloud. So the community cloud allows systems and services to be accessible by a group of organizations. This means it is not exactly a private cloud nor a public cloud, rather a, a domain which is basically accessed by specific groups that are given access to perform any action or access the features from the cloud. Hybrid cloud. Hybrid cloud is basically a combination of your private cloud and the public cloud. So, why the hybrid cloud is required when we are having both a private and public separately? Well, for an organization, security is one of the important key points while designing an IT infrastructure for deploying their application stack. Normally, any companies would try to keep their data secure, and in the process they would always take private cloud as the platform where they can host the critical or reliable data that is that they don't want to get exposed outside of your organization. For example, you can consider employees payroll data as kind of critical data that needs to be secure and needs to be accessed from outside the organization. While on the other hand, some of the data, such as mostly accessible applications which are in public domain, need not to have data that needs to have more security. In that case, they can go using a public cloud. So that is the reason why a hybrid cloud is now a very important cloud deployment model in today's IT infrastructure arena. Now let us discuss about the service models. Service models typically allow to break our cloud pyramid into three different structures. One is the infrastructure as a service, one is the platform as a service, and one is the software as a service. Traditionally, we need to have an on-premise infrastructure where we would be having our physical servers, rack and stack on our data centers where we would be running our own operating system and using certain virtualization tool. We would be basically creating multiple processes or VMs where we can run our middleware system, and on top of that we can run our runtime applications on top of it. So typically this is kind of a monolithic stack where we have the entire infra and application stack together on the same infrastructure, on the same data center. And it is the responsibility of the client to manage from bottom to up all the required stacks since it is hosted in the client environment. With infrastructure as a service, the the OEM vendors, or we call as the hyperscalers, they manages the storage, the networking, the servers, virtualization, and the operating system running on top of it. While the client manages the virtual machines that they are creating using their own host operating system, the middleware, and the application that they intend to run on their virtual machines or the virtual machine stack that they are creating. When we go from infrastructure as a service to a platform as a service, the responsibility of managing the downward stack that comprises both the in physical infrastructure resources as well as the middleware relies on the ISP vendors, the OEM vendors, or the hyperscale, whosoever is managing it. While for the client is just the application and the metadata. That means the application runtime dependencies and the libraries, which they only manages. Our Cloud Foundry will fall in the platform as a service because here we are simply concerned with deploying the Cloud Foundry platform without thinking what would be our underlying infrastructure. We would be responsible to manage end-to-end operation on the Cloud Foundry and just to make sure that our application gets deployed properly on the Cloud Foundry stack. While from the platform as a service, if we move to software as a service, the entire stack, right from the storage, networking, servers to the application is managed by the vendor, and the application are provided as a service to the end user who can directly access it. So as in where we are moving from this stack, right, from the left, from the traditional on-premise to a software as a service, we are basically doing customization. That means we are basically bringing more value addition to our IT infrastructure stack, and therefore the overall OPEX cost, operational expenditure gets reduced, and we are able to manage our application more seamlessly. Now let us work or know more about the infrastructure as a service. So infrastructure as a service is the delivery model that provides on-demand scalable services. It provides access to the fundamental resources that is required to create virtual machines such as compute, storage, and the network. Some of the properties of the infrastructure as a service include billing, which is based on the usage or the consumption of our resources. It provides a multi-tenant virtualized environment. This means that we can create multiple co-isolated environment for different application stack to run together without any sort of friction between the application stack. So they will be working independent when they will be operating independently, one without relying on any other application stacks, and end users won't feel that within the same virtualized stack or the infrastructure service we are running multiple application stacks. And also it can allow or facilitate multiple teams to work together in the same infrastructure stack. It can be well coupled with the managed services for OS and the application support. So some of the example of the infrastructure as a service include Amazon Web Services, Microsoft Azure, Google Cloud Platform, and VMware OpenStack. Now let us move to the platform as a service. So platform as a service, it provides the runtime environment for your applications, development and deployment tools. It basically provides all the facilities that is required to support the complete life cycle of your application, right from creating the application stack, deploying the application stack, managing how your application should start and stop, and then monitoring your application stack. What are the basic properties of this service? Properties are that the applications are developed with particular platform in mind. It is also usually multi-tenant, that means it can allow multiple teams to work together on the same environment, and it's highly scalable multi-tier applications. So because of the easy nature, it basically helps to provide more scalability to your application stack so that it becomes cloud friendly, and basically it allows to run multi applications onto the single platform infrastructure. Some of the examples include Pivotal Cloud Foundry, Docker, Kubernetes, and Red Hat OpenShift. Next, we come as the software as a service model. So, software as a service, it provides the end commodity as an application that the user can directly access, and it is a software development methodology that provides licensed multi-tenant access to software and its function remotely as a web-based services. Some of the properties include that they are again built based on the usage or the consumption of the application. They are usually multi-tenant. That means again the applications can work for multiple teams irrespective of whether the application is running on the same infrastructure or not. Again, it provides a highly scalable multi-tier applications stack. Example includes Salesforce, Google application, NetSuite, Postgres, etc. So we studied about different cloud models, both from the deployment and from the service perspective. Now let us see what are the advantage of this cloud delivery models. The advantage obviously is enormous, so we'll just give the basic and the most critical advantage that our cloud delivery model provides over the standard on-premise installation systems. First of all, it lowers the computer cost. Secondly, it improves the overall work performance because with cloud we adopt the virtualization technology where we can actually create faster or create machines in a very quicker manner compared to how we used to provision the physical server resources. Third is the reduced software cost. Fourth, because we are actually managing the servers from a virtualized standpoint, so software update becomes very easy. Improved document format compatibility, unlimited storage capacity on the hard disk, as also onto different data storage that can be mounted externally, increased data reliability, a universal document access. Latest versions are always available because the cloud models or how they work is basically we adopt a continuous integration, continuous delivery process to provide quicker update on the underlying infrastructure. Easier group collaboration and device independence. That means that irrespective of any device that you have, whether it's a workstation, whether it's your own laptop, whether it's a mobile device, the application will seamlessly perform in the same manner irrespective of any device. But with advantages, we always have some drawbacks. What are the drawbacks of the cloud delivery model? It requires a constant internet connection, does not work well with the low speed connections. So we require a good bandwidth to facilitate because all the software binaries and the packages are always and they are always kept in some shared repositories which are not on co-located on the same IT infrastructure. It must be somewhere. So we need a good bandwidth to download those binaries and install them on a physical infrastructure. Feature sets are always limited with compared to the on-premise system because here we have to remember that we are actually bringing up a cloud infrastructure to create scalable and fault-tolerant applications. So there are many points or you can say integrity issues that remains when we compare with a standard on-premise system, such as we need to basically adapt more onto dynamic configuration so that our applications can pick up the database connectivity dynamically rather than statically allocating it on a configuration file. Therefore, what happens? We get to have limited feature set when we actually compare with an on-premise system. But that is not always a bad point, because in any way with cloud we want seamless connectivity and user experience. And if those features can be rectified or can be brought into some other feature sets over cloud, that is always welcome. It can be slow sometimes, again because of the network connectivity. Stored data can be lost, yes. So data stored on a particular virtual machines are always everywhere in it. That means whenever the PLD is destroyed, the data gets lost. So a good practice is always to store the data in certain physical storages, so that we can mount it as and when we spawn up a new virtual machines. Stored data might not be secure. This is because we are not putting any kind of security implementations on storing the data. But this can also be done if required. So with this, we conclude our session on the cloud technologies. Here we talk about what cloud is all about. What are the different cloud models? Primarily we focused on deployment models and the service model. Then we saw different variants of the service model. We then focus on to know different type of the deployment models, primarily the infrastructure as a service, platform as a service, software as a service. We then look into the pros and cons of cloud delivery models. I hope this session has given you a good idea on the cloud infrastructure, and with this we will be able to start our Pivotal Cloud Foundry course, and I hope it will be easier for you to understand the platform very in a very lucid manner. So with this, uh, it's time to say bye, and we'll meet in our next session. Thank you.